Okay, so moving and going a little bit into details into the two-site stretch configuration. And as we said, this is Metro DR, we called it with ODF, and Infusion is also part of the DR options that you have available when using Fusion and Fusion Data Foundation. This is like the underlying brains of the solution, we could say. This is the Ceph configuration that we have in place to be able to work and do DR with Fusion and ODF when we're working with OpenShift. So things to mention here, and I will show you through the CLI in a moment. I have 3 data centers. In my demo, there are virtual machines running on different subnets. Here you can see that I have 2 data sites. I call them data sites because they have OSDs, they have actual drives, so they are in the data path, and they are connected with 10 milliseconds or round trip time, again, because we want to have low latency, because they're in the data path, and it's important for the acknowledgement of the client, so it is low and the performance is a good experience there. And then I have a third site that is our tiebreaker site, where I have one node running in it, and it's basically a monitor. So as we said, this is a very light operation here. It doesn't need a lot of resources. It could be in a virtual machine. It just runs a monitor service and is there to help us with the tiebreaker solution, so we can keep quorum even if we lose a site. Again, this cluster as a whole is going to be able to offer block, we could call NVMe over Fabric, RBD, however we want to consume the block. It will also be able to offer NFS, CephFS as our shared file system, and also we have SMB coming in the short future that also will be part of this. We don't need to do any special configuration here, and that's a nice thing because all of the stretching, as we mentioned before, is happening at the RAIDOS level. At each OSD is actually stretched. So everything that we have here, S3, block, and shared file, is already stretched for us.
So it's happening below the protocol in the stack, right?
Yeah.
So
yeah, it's happening below the protocol. So the nice thing, or the only thing that we really need to be aware of is that when we position our services, we need to be sure that at least we have, if we have gateways, no? And I will take RGW as an example. RGW is like the S3 endpoint. So it's our object gateway endpoint. It's just a service that is running on a host. So what I need to be sure is that I at least have one RGW running in each of my data centers. So if I lose a data center, I'm going to be able to access through the other one, no? So it's just a couple of things that I will show you in a moment in the deployment that we need to take into account, so we don't have a single point of failure that we created ourselves, no, by not having one daemon, one service on each of the sites.
Mm-hmm.
Okay, so let me go here into the CLI and just show you a little bit from the CLI. Can you see this kind of size? Okay, Randy, shall I make it a little bit bigger?
No, that's good. Looks good.
Okay, so just very quickly, this is a Ceph -s command. It's the Ceph status. As you can see here, we're health okay, so everything is running fine. Our monitor, we're talking here about the Ceph services. Our monitor, we have 5 daemons, as I showed you there in the diagram before. So we have from 2 sites, data center 1 and data center 2, and then we have this Ceph node 6 that is our tiebreaker. And I will show you this from the command in a moment. Then the manager, we also have 1 active and 1 passive. The manager is really in charge of several things, no, but provisioning of volumes. For example, if we're talking about OpenShift and ODF, it takes care of also gathering metrics. It takes care of different sub-modules that are running there that make Ceph tick. No? So it works in active-passive way, so we can just have one active in one site and the other one passive. If we lose one site, the other one is going to kick in, get into active mode without doing anything for the client, no, completely transparently, and it's going to get things going. And finally, we have 12 OSDs, and all of them are up and running. So let me show you at the OSD level with a Ceph OSD 3 command. It's very visual here to see our configuration. No? So this is my crush definition. We always need to have like a root, the higher level. But then what I have done is that I have configured the data center, TC1, and I have added 3 nodes under DC1. So we have 3 nodes under data center 1. And the same with data center 2. So I have added 3 nodes. Each node has 2 OSDs. Okay, so the OSDs is the actual drive where I'm going to store my data. No? So this is like a logical representation of my physical division in our data centers, in our racks, etc. No? So why is this important? Because once I create a pool that I will show you in a moment, a pool really is where we actually store the data. So if a client wants to do a read or a write, he needs to write into a pool. No, that is like a really logical representation of a space, no, that he can use for a specific block, for object, however we want to call it. So when we are configuring a pool, we normally configure the replication schema. The replication schema being, okay, I want to have two copies, 3 copies of my data. I want to use erasure coding. I want to, so per pool, you can have a different configuration on a normal Ceph cluster. Here, when we're talking about a stretch cluster, it's a requirement, it's a must that you use replica 4. No, that's a full requirement because we need to be sure that we are keeping 2 copies in data center 1 and 2 copies in data center 2. So I can be
at least replica 4, right?
Yeah. Yes. Yeah, you could go higher, but by default, even if, let's say, you have configured replica 2, once you enable stretch mode, no, and that you actually press the command, okay, I want to go into stretch mode, automatically Ceph is going to go through all of your pools and set replica 4. So it won't allow you to have anything lower or any local pools. Everything goes into stretch. And let me show you that a moment. If I do a detail here. Yeah, this is not the most visual, but you will understand here in a moment. So I have 2 pools, pool 1 and pool 2. Very basic. Manager, this is by default. So let's check this one. RBD pool is my block pool, no? And this is the one that I'm going to use for the demo. So here I can carve out volumes to present to my clients, and they can use those volumes, that block, to do reads and writes or whatever they want to do. So here you can see that my size is 4. And by size 4, I mean that I want to have 4 copies of that data. Okay, you can see that we're in replicated, and I want to have 4 copies of that data. This is the first part. I want 4 copies. Then really what's important is actually the crush rule. The crush rule is where do you or how do you want to store those 4 copies? You could say, okay, my failure domain is data center. If you tell him, and that's what I have configured, if I tell him my failure domain is data center, he's going to be sure that he stores 2 copies in this side and 2 copies in this side. If I, for example, say my failure domain is host, he's just going to make sure to store 2 copies in any of the hosts, no, to have 4 in total. So it really depends on the failure domain that you select with your rule, that you can be sure that you can lose a full node, a full rack, a full data center in our example. No?
Okay.
Yeah, you can see here, this stretch rule is the one that is actually being marked here, and my size is 4. This means that I'm going to have 4 copies, and 2 copies are going to go into each site, so I'm sure that I can tolerate a full site failure. Min size 2, if people are not used to Ceph, what min size 2 is like the minimum amount of available copies of the data I need to have to allow clients to do reads and writes. So with this configuration, you will need to have 2 copies active to be able to read and write. If we go under that value, then the IO, the client IO, is going to freeze.
Be suspended, yeah. Okay.
Yeah, so that's something important. Afterwards, you will see how when we go into stretch degraded mode, this is actually going to change, and I will show you how that goes. Okay, any questions from this one? Does it make sense more or less?
Yeah, no, it's pretty straightforward. I mean, the output's pretty clear.
Okay, let me just go into the monitors. We covered a little bit the OSDs, and I just want to show you the monitors with a dump of the monitors just a second, just so you also see how they have a crush location. A crush location, again, means the data center to which they belong. So then Ceph knows how to play with these. And the main difference here that you can see is that Ceph node 6 is actually DC3. No? So if I just go back here a moment, you can see that my tiebreaker site, Ceph node 6, is actually the one that I have configured as a different data center. And you can see here that the tiebreaker specified, the monitor specified as a tiebreaker is Ceph node 6. So in that case, he's going to be the one that decides if there's a network split, if there's something going on, the side that is actually going to remain working and is going to keep the operations going. Important things to notice here, stretch mode enable 1. This means that it is enabled. If it's 0, it's not. So here we are already running in a stretch mode. I have configured my cluster and it's running in stretch mode. And the election strategy is 3. Election strategy number 3 is connectivity. So in Ceph, when you're talking about monitors, you can have like different strategies to do the voting or to get to the quorum, etc. when it is required. Connectivity is kind of an advanced strategy for when we are trying to reach quorum, by which Ceph actually, based on the connectivity, so on the health of the connectivity to all of the sites, how they have been behaving, he builds like a score, a ranking of all of the different monitors. And based on those results, on that ranking, he will take decisions on who can be the leader, who should be part of the quorum, etc. No? So it's really kind of an advanced mode that helps you with this kind of data center stretch cluster configuration.
Now, you may have mentioned this, but what happens if the monitoring node fails in the tiebreaker situation?
Yeah, if it fails, there's not going to be any issue, because what you really need to have is like more than 50% of monitors available. We still have 4 available. We're just missing 1. So there's no special consideration there. He will just work as normal, because we still have more than 50%. No?
Got it. Okay.
The issue would happen, just so it is very easily to see. Now, if we only had 4 monitors, we didn't have, let me go here. No? If let's say that this tiebreaker site didn't exist, if we only had 2 monitors here and 2 monitors here, if we lose a full site, we only have 50%, because we had 4 monitors, we have lost 2, we only have 50%. We don't have enough monitors to form a quorum. No? So then all of your client I/O would be interrupted, and that's why this plays such an important part. No, having it there, that tiebreaker monitor.
Yep. Okay.
Okay, perfect. So with this, I think that we had like a brief introduction. I just want to show you one thing more that is actually useful for afterwards. That is pools. When we talk about pools, and if I do a detail here, they normally have a certain amount of placement groups. Placement groups is not really a thing that we should worry about as an end user or even as an administrator too much. If you're doing Ceph administration, maybe you do need to understand it, but it's not the thing that is every day in your user work. But I want to explain it so it's also clear how this works. Now, if what a placement group is actually an aggregation of objects. So one PG, one placement groups will be X amount of objects. And then when a pool wants to do certain operations on placement groups, a pool has, like this, in this case, 32 placement groups available. He can work with the placement group. So the placement group is the one that is going to have a replica, is going to do the replication. The placement group is the one that is going to be assigned to an OSD. In this case, it's like a higher entity on top of millions and millions of objects, just to make the operations easier. Because otherwise, trying to calculate where an object is, if I had to do the replication per single object in the full cluster, when we are talking about billions and billions of objects, it's just impossible to manage, and the CPU calculations will be huge. No? So that placement group, that higher entity, helps us manage all of the objects that are inside a pool and that we need to access, replicate, recover, etc.
So it's a logical grouping of objects. Okay.
Completely. It's just a logical aggregation of objects, and then we do operations on placement groups instead of single objects. No, that would be crazy. So I just wanted to show you here as an example. This is the output of my placement groups. We have them listed here. The first number that you have here is actually the pool ID. So you can see that pool 2 RBD pool is here. I have 32 placement groups. That's why, well, here I'm actually filtering some of them. No, but this is the different PG numbers, and the first one is the name of the pool. What I really wanted to show you here is this part here. This is what is called the active set. These are the numbers of the OSDs that are part of my configuration. So let me clear this so it is clear. And if I do a PG like this, that is easier. And then I do Ceph OSD3. I just want to show you a thing so it is clear. So this is one placement group, and this is the active set. This is all of the OSDs that have a copy of the data. So as you can see here, if we check the number of the OSDs, these two are going to be from site 1, from data center 1, and the next two are going to be from data center 2. So in this way is where Ceph always makes sure that you have 2 copies on one side and 2 copies on the other. So if we check like 1 and 3, you can see here 1 and 3, we're under data center 1, 9 and 11, we're under data center 2, no? 9, 11, and 9 here. So I just wanted to show you this, just so we can check afterwards, once it fails, how this is also modified. But up to this point, 2 OSDs per site. Every write that the client does to this placement group is actually going to be stored, copied, replicated into these 4. Okay, so let's move along, and let's do in our demo. What we're going to do is kind of this. We're going to actually fail a full site. We're going to lose all of the nodes in that site. We're going to simulate the failure, and then I'm just going to go through the things that are happening so we better understand what's going on. So what I have ready to help out with this is a small application that is going to make us visualize this easier. So what I have here is just a demo web application that is actually writing to this file. So it's constantly doing reads and writes. This file that you see here is actually a file that is mounted on a block device. Let me show you that just so it's clear for everyone, that there's no mystery. So here I have my block device, block RBD. This block is being provided by my stretch cluster. I have created a file system on top, and I have mounted it in this file system where I have data. And this is actually, you can see here that this is the one that the application is reading and writing always to the same file. So it just opens the file and it appends and it reads from the file. So the idea with this demo is that we're going to actually fail one full site, and we will see what happens with application that is constantly doing reads and writes. You can see here in green that there are writes and the latency for each read and write, and then we can just take a look at what goes on. We also have here a visual representation of the data centers. So once we fail the data center, we should see this go in red, and then we should see some IO interruption, and then we can see what goes on with Ceph. So let me just stop the nodes. As you can see here, this is kind of a forced stop. So it would be equivalent to a hard stop on the nodes that I'm going to do. I'm going to stop DC2. Okay, so I'm just going to stop these. We can go back to our Ceph status that we have here. And we should see here these go in red. And also, as you can see, our client IO is going to be freezed or paused until Ceph recognizes that the OSDs are down, and he actually starts reading and writing again. So he has to go into a stretch mode. So he has a certain period of freeze until he goes into stretch mode. Right now, you can see that he has already detected that the monitors are gone, and that now he only has the monitors with 3 of the nodes, and he's still going into a stretch mode. And now once he reaches a stretch mode, you can see that our client IO has gone back. So as we said, we don't lose any data, only that the data is frozen. So if you were writing to a file system, you would see how that file system is hanging during these 38 seconds. Normally, this can change between 20 and 30 seconds. You can also configure it. So you can configure it through parameters, so it can be less. The only thing that if you go too low with your detecting the failure, you can also get false positives. No? So it's really finding the balance. But this is like the freeze time is for Ceph to detect, as you can see here, that my data center has gone down. So all of the hosts are down, all of the OSDs for that data center are gone. Once he detects that, he enters a stretch mode, and then is when you get back for the IOs working.
And
So
are the IOs buffered or stalled at that point? It just stalled basically.
yeah, well, depends on the client. That's a little bit
Right.
more on the client. So if the client can do buffers, they will be doing buffers. If it can't, then it will be actually stalled. No, so
It's
it
more
depends a
application
little bit on
dependent.
the client.
Yep. Okay. Cool.
Yeah, so here you can see that 50% of my data is degraded, but everything is active. In Ceph, when you see active, is that we are serving client IO. No? So you can see here a list of my placement groups, and you can see that 80 of them are undersized degraded and 15 are active undersized. The only thing that needs to worry us here, and this is very important, is that they are active, meaning, as you can see here in the demo, that because they're active, even if they are undersized, they can still serve IO. What undersized means is that, hey, you told me that I need 4 copies, and right now I only have 2, so I'm undersized, but
Yep.
I'm serving client IO with those 2.
Okay.
Let me show you very quickly what this translates to in the pool. No? So if we do the details of the pool, no, sorry, not this one. Let me see if we have it. I will do it here. Details. This one that I showed before. So I just wanted to show you the difference here. Size is still 4. I still want to have 4 copies, but what I have done is that I have lowered the min size from 2 to 1.
Yep.
Why do I do this? Is because, okay, now I have only one site, I have 2 copies, but if one disk goes in this remaining site, let's imagine that my site is down for 1 month. This is something, it's a little bit crazy, but it could happen. If my site is gone for 1 month, I need to manage all of the operations with these 2 copies. So during that month, it could be possible that I fail another drive, that another drive goes. So if another drive goes, I still want to keep serving IO. So that's why I changed min size 1. So even if I'm left with 1 copy only, I can still serve IO to the clients. Min size 1 is a little bit dangerous in the sense that you only have 1 valid copy at that point, and you're writing to that copy. So it's not something that we will recommend, but here you are working in an extreme case. And also, we do recommend and we support this configuration with Flash NVMe, well, Flash in drive. That could be SSDs or NVMe's. We support it with Flash media. Why do we do that? Because once we recover the site that is gone, we want to do it as fast as possible. And also because we are running with min size 1, we want to really lower the failure of the disks on the remaining site while we are with one failed site. No? So we want really endurance from the drives. We don't want to have a spinning disk failing every 10 minutes. No? So that's why a little bit to understand the requirement of using flash drives for this kind of setup.
Sure. Okay.
One final thing, just to show you the PG map that we checked before. No, you remember that we had like 4 OSDs marked here. Now, when we go into stretch mode, we actually change the peering policy, and we allow for a placement group to go up to serve IO, to go active, even if it's only with OSDs from their same site. So let me just make this more visible here. I will do again the Ceph OSD 3. Let me get it here. Yeah, so as you can see now, we're only remaining with 2 active OSDs, 1 and 3. So as you can see from data center 1, that is the one that is remaining. So I am able to have my placement group active, up and running, but with only placement groups copies from data center 1. So that also happens when we go into stretch mode. It will allow us to do this kind of operation and keep client IOs working as expected.
Okay.
And just let's recover. Let's start this just to see the recovery. There's nothing too special here, but we can do a start just to recover our nodes. So during recovery, what will normally happen is that we will see the nodes going back into the cluster. The OSDs go back up. And when they are up, they need to talk with their peers, with the other OSDs in the other side. And they need to start seeing, okay, what has changed? No, they go like into recovery mode and they start looking for what has been changed for one cluster and the other. This is called like the recovery procedure. Once all of the data has been copied to each of them, then everything will go back to working as normal.
Okay.
So as you can see here, they're in the peering state. Peering is when the OSDs talk between each other and they decide which one is behind, what they need to copy to others. So they're really talking and deciding.
So they resynchronize. Yeah.
Yep. Exactly. Cool. And you can see here that slowly we go into, well, sorry, it was quite quick in this case because not a lot of data changed, but you can see here how we're going into active clean and we go back to health okay. And during the recovery, because we need to, again, move a little bit the primary OSDs, we had like a small freeze. This is much smaller than we actually failed the site, but you can see that there was also like a 1.2 second freeze when we did the recovery, just because our primary OSDs need to be reshuffled a little bit again. Yeah. So yeah, that's something to take into account when you're doing this kind of configuration.
Very cool. So how much of this, how much of the CLI data or the visualization that you showed is exposed via like the UI? I know we're going to talk about that in a subsequent episode, so I don't want to jump the gun, but
yeah, so when you are working, like you would see kind of all of the like the red that you're seeing here, you would see, and you have alarms configured. So you have monitoring with Prometheus Alert Manager. So all of them will go reds with site down, data center down. You would get, if it's a pager or if it's an alarm, depending on your configuration, because the UI allows to configure SNMP, whatever you need, and so you will get alarms triggered by that. In the meantime, as you can see, I didn't really touch anything. So it's like self-managed. So you don't need to do a lot, but you need to know that something has happened. So you would have this information and alarms firing off in your UI. And then you could also check, because we have Grafana with Prometheus. So we normally have exporters, node exporters that send all of the data into Prometheus. So then you could go into the OSDs, and there you would see the latencies that you have been having during this period when doing reads and writes. You have all of your nice graphs in Grafana,
Okay, cool. Yeah, this is great. I mean, I think this is a really good way to represent the resiliency, right? Because I think we tend to think about Ceph more as just being flexible, multi-protocol, and it's important to understand how hardened it is as well. So that's very cool.
Yeah, and just for people that maybe are interested in Fusion, just so it's clear, you could imagine that you have ACM here in the middle, and ACM is really the one that is going to take care of moving your application when a failure happens. So when one of these sites goes down and everything burns, ACM is the one that is going to move your application to the other side. He's going to take care of making the PVs available here, and then your application is going to go back to reading and writing as required.
Cool. So that's all happening behind the scenes with Fusion Metro DR, right?
Yeah, with Fusion and Metro, everything is automated. You need to take care of your app because the failover is per app. But once you consider a site down, all of the worker nodes in that site are considered down, and then you need to move, or really ACM, you need to press the button, not really the red button to say, okay, switch over my applications to the other side, and then it will move. But all of the underpinning is really this stretch cluster that you can see here, the one doing, like, let's say, the magic under the covers.
Now, this could also be relevant or applicable in the case of maybe an on-prem instance and then maybe one running in a cloud provider as well, depending on how it's configured.
Yeah, it's not something that we normally do because of the latencies, that you would normally have between the on-prem. But if you could have like really low latencies, there's nothing technically there that would allow this or would impede this to work. The only thing that you need to be very careful is, as we talked, with the latency between the data sites, the ones that have the OSDs.
Okay, yeah, makes sense. Awesome. Well, this is great. I mean, this is very useful. I think this answers a lot of questions that people have in terms of the, robustness and reliability of Ceph and how it's managed and optimized and automated. So very, very cool. And in future episodes, I think we're going to talk about some tiering enhancements and also talk a little bit about Ceph ADM, which is kind of an easier way, I guess, to manage some of these processes rather than doing it via the CLI. So.
Cool. Yes, Yeah, for sure. We can go through and also cover a little bit of the asynchronous side of the replication. And as you said,
Yeah.
there is a lot of automation. And I didn't show it, but just before we close, I can show
Sure.
just very quickly that I forget is that all of this, you can see here that no, my data center one, my node belongs to node one, all of this, I just did it with a single file. So when I bootstrap my cluster, when I configured my cluster, I just used one single file. Let me just find it for you. That is here.
Oh, okay. Yep.
And
Right.
you can see here that this is a single file that when I do, okay, install my Ceph cluster, what I can tell it is that you have different services in the same way that you have RBD, RDW, you also have a service type that is host. And then what I'm really telling it is, okay, deploy this host, add these labels. By labels is really, I'm telling it which services he wants to run. But I'm also giving it a location. So I'm telling it that he belongs to data center one. So all of this is done in a single file. Then I just run, you can see here I have DC2, etc. No? And I also have my managers with the labels and the placement. I'm actually making sure that I have them in both of the sites. But this is really, really easy to consume in the sense that I only build this single site, the single file, sorry. And then with the bootstrap command that you normally run, you are ready to, I don't have it here, but you're ready to deploy, you know? So in that sense, Ceph ADM, as you mentioned, gives us a really nice orchestration experience because it's going to allow us with one file definition to declare the state of the cluster that we want to reach, and then everything is going to build for us.
Yeah. So it makes provisioning and management really, really simple. Yeah. Very cool. Awesome. Well, this is great. Really good stuff, Daniel. Thank you for taking us through it. So again, in a week or so, we'll come back with the next episode and drill down a little deeper on some of the more advanced features, but this has been super helpful. So thank you. And thanks everybody for watching. We appreciate your time, and we will be back with another episode soon. So thanks everybody for watching.
Thank you.